want to be able to pulse it at different frequencies. And I'm hoping we can just smell it in the center. I gotta go get my tool bag. I'll be right back. Yeah, we were just testing out for frequency response of this coil with the meters and the pulse generators that Kirkwood had in his home, which are analog based, and they can are immune to a lot of like digital noise or any kind of digital processing that you would encounter. And it's all analog based vacuum tubes. So pretty neat stuff. Those are they don't make them like that now. Maybe for high-end experiments, but so we were doing an impulse based on a schematic from Daniel, and then we were watching the response to see if there was any like over unity or output or something anomalous that's not conventional. We did not see any of that. So what I'm trying to do now is just to pulse it. I'm not particularly looking for a specific frequency. I just want to be able to see if I could dial this in and see if I could smell that ozone he had produced at the blessing ceremony when he brought it over there. So that's what we're going to do.
Okay, could you talk a bit about how the first order and second order effects? Is it possible that we could be seeing over unity on a second order set of stuff, which is only possible to see when we're dealing with nonlinear experiments?
Definitely nonlinear will put you in a different category.
Of measurements?
Yeah.
Can you tell us a little bit about the problems, if you would just explain what Daniel's argument was, that because could you just tell us about it?
Okay, there's two things here. When you're just watching volts and amps with meters, whether they're RMS or not, you don't know how apart they are in phase with relative to each other, so you don't know what the true power requirements are, because they could be fully out of phase and have VARs instead of watts. And so the problem is trying to figure out how the waveforms, both amps and volts, are close together to see if it's producing usable watts. So meters, just digital voltmeters, won't give you that unless you have digital processing inside that can do that. And I guess the more expensive the meter, the more flexibility you'll have to see in that real time. Now that's digital, which again is immune to digital noise, and how I don't know if this is going to affect that through this circuitry. So it's just to take out all those kind of noise variables or radiation variables. You kind of, if you go analog, it's usually a best approach. I don't have those kind of meters, but what I do understand is that linear elements will react with standard electrical engineering terms. But when you start varying the parameters of capacitor inductors in time, and I'm talking about an inductance that's static, if you could make it dynamic, whether you spin it or you change its parameter internally by, say, putting something in series and parallel at twice the frequency of its fundamental, would create possibly an underdamped or overdamped situation depending on how you designed it. But what you're looking for is an underdamp so that it grows in time. So as you're storing energy in parallel, you're releasing it in series for capacitors and the opposite for inductors. If you do that at twice the frequency, you're going to be transferring, from what I've understood in the literature, transferring energy at different frequency, from one frequency at a high high frequency point to a lower frequency point, or the other way around. So you're shifting the energy in the time domain, which when you apply it to variable inductors and capacitors, you could transfer energy or amplify energy in that way. And that's what I'm looking for. But for that to happen, it needs to be dynamic elements varying in time with the voltage and amps from a source.
Okay, so yesterday we did not have instruments set up to measure in a non-linear fashion over time.
No, we were driving everything with sinusoidal, very standard, very steady, very by the book kind of experiments. And I think what we got to do is find nonlinear doors or phenomenon in these things and exploit them so that we can extract energy from it. And it's true that if you can agitate your environment to the point where the environment pushes back into the system, that would be the ideal way of extracting energy, whether it's temperature or whether it's like electric or magnetic. One way to do that is when you do the nonlinear elements and you're varying at a rate of change that's not your standard dLdt or dCdt, or the variable of capacitors a very linear, or variable of inductors in a linear way. If you could do it non-linearly, then you introduce a derivative of the element which needs to be accounted for in the whole circuit. And when you do that, you can have second ordered or third order effects, and you have to see how that plays into the circuit with both voltage and currents produced by the elements as they change, and from the driving circuit that's getting that element to activate. So there's potential there for solid state generators that are not moving, but the elements are, parameters are changing in time.
Okay, so in order to set up an experiment that takes a series input and output and looks at things over time to get to these second parameters and third order parameters, third order phenomena, well, what should we set up? And would you be able to set up something like that? I mean, how would you set it up?
Well, you have two coils here. If you could, in one, you figure out its fundamental, whether it's in series or parallel. And then what you do is you switch series and parallel, series and parallel, series and parallel. And since this is in the kilohertz range, we should be able to get circuits to put the coils either in series or parallel with ideal diodes, which it's an active diode circuit arrangement where you can turn it on and it'll pass current either way, and then turn it off like an SCR and it'll stop. But it's both ways, and I could show you one. I have one from this company in San Francisco. But anyways, using 3 of those and then using 2 elements, you could put them in series and parallel at a frequency that you can control, and then you can send a signal out that's half of that frequency that you're series and paralleling the elements. That would, even though this is static, that would change this to a very dynamic element from twice the inductance when it's in series and half when it's in parallel. So that effect there could bring about that nonlinearity I'm looking for. I'm looking for nonlinear results by nonlinear stimulation, because everything else is by the book. You'll never see anything out of the ordinary if you do linear results.
Okay, so if we set up the experiment as you've described, would you expect to see, and in what form would you expect to see some workable energy?
The voltage will grow over time. I don't know what the amps will do. I think that'll stay constant, but the voltage will keep increasing, and I don't know if the circuit will be able to handle it. So if anything, it'll just blow up within the first microseconds or milliseconds. I don't know. It depends on the fundamental and how fast you're driving it. But the way to get around that would be to put a spark gap and see that it tip over the energy. But what I'm looking for is underdamped energy production from variable elements in time, nonlinear, and you can drive them into nonlinear dimensions, and then that in itself will play in other dimensions that we haven't looked at. Second order, third order effects of electric fields. What would that do to space around it? Or the magnetic field, second order and third order magnetic fields, what would that do to the space around it?
Okay, do you agree that the experiments that were set up do not demonstrate over unity at present? I mean, Daniel's claiming that he's lighting more than it's possible to light. Kirkwood was saying, this is completely physically possible with all of our present understanding.
Yes, it's very standard what he's doing, and his load is nonlinear.
And
it's a diode, so it's not going to be a linear response at all. If you drive into high amps by pulsing it at short duty cycles, yeah, you could drive it to illuminate more with pulsing as opposed to DC, and it's a nonlinear load. To simulate a nonlinear load on this system, you would need a nonlinear dynamic resistor. Or a resistor that's variable in time, so you could change it so that it becomes nonlinear how you want it when you pulse it at that frequency. If you could simulate the nonlinear characteristics of a diode with a resistor and emulate that and see if it truly does that, then yeah, it would
okay, so
be similar.
How can we set up this measurement of a non-linear setup? How can we get a non-linear load and measure it? This experiment that you gave us the example of, would that do the job?
That's already nonlinear because it's spinning in space, that inductor. The way to do this one would be to change inductance in time. So I guess you could say the nonlinear load here would be the variable inductance of this in time. Parallel and series of both coils.
So how can we do that?
I don't know from the top of my head. I would have to look at it. But I did mention how you can series and parallel something which is ideal diodes.
Okay.
Which is active OR-ing of diodes.
Okay, so still it's inconclusive if there's over unity here.
I haven't seen physically myself the over unity. I do know that this thing puts out ozone when you drive it at from 20 to 50 volts, and the output is still in the hundreds of volts. I don't know where that's coming from. My speculation is the magnetic field intensity in the middle of this coil creates high magnetic stresses between nodes enough to do a high voltage stress in the center to the space inside.
Okay, and Kirkwood says that's possible at low currents.
Okay.
Okay.
Yeah. So I don't know what it would take. I do know that you can do it with electrostatics with a high voltage transformer and doing it electrostatically, but we're using magnetic fields here to create a high magnetic stress field, causing that in itself would cause high voltage stresses into space around it if it's compact enough. And I just want to see if I could smell that right now.
Okay, let's see if we can do.
Okay. So, I'm not good with interviews.
You're very good. That's very good. So what you gonna do?
I'm gonna provide power to this for now. Let's see. Plus here. And then I'll just put the load right in. This is a motor driver. I don't care about the waveform. I just want to see if I could smell the ozone at whatever voltage and current this thing's putting out. Okay, so I don't need those banana clips. You have here.
So you call them banana clips?
Yeah.
That one goes right through all of them.
Okay, so this is minus.
I'll come back in a sec. Let's just go see. I asked Kurt could very clearly. Does the computer? Oh yeah.
So we have electricity.
What have you got?
Electricity.
Yes.
Good.
Excellent. Okay, so we asked him, does it create, is it normal at low levels to have a field this concentrated so we can create ozone? He says, there's a dearth of published data relating to magnetic field-induced O3 generation. Calculation of the field geometry and differential magnitude gradient to affect the oxygen pairing from O3 is non-trivial and cannot be simply established in quantity as a loosely slated conditional normal at low levels. No, the situation is probably manifest in the central bore of one of these coils, but not at all an easily modelled parameter of an ionization threshold by any means. See what we're dealing with here. Okay, so I'll take that as a no. Otherwise they'd be doing it with low voltages all the time as opposed to really high voltages online. Okay.
It's not trivial. Well, let's read it again. So that way we can.
At the bottom there.
Bottom here?
Yeah.
There's a dearth of published data relating to the magnetic field-induced O3 generation. Calculation of the field geometry and differential magnitude gradients to affect the oxygen pairing to form O3 is non-trivial and cannot be simply established in quantities as a loosely stated condition, normal at low levels. No, that situation is probably manifest in the central bore of one of these coils, but not at all an easy modeled parameter for ionization threshold by any means. So it's hard to do. It's hard to get O3 pairing with magnetic fields, and meaning that you would have to create high magnetic stresses, and to do that here with low voltage, low currents would be impossible. So if we can smell ozone at low voltage, low amps on these coils, there's again something new there to be explored and looked into.
Okay, cool, thank you.
So,
Sorry.
can we just experiment?
With the vice
We came to this facility because it was open to the public today, and it's basically an electronic shop where people can come in and develop and test things, and it's
Yeah, this is a tool.
I know, that's what I'm asking. Sorry, just doing my white balance here.
Yeah. And just people come here and work on electronics and try to go to seminars here, and it's open for people to come here and join and work on electronics.
It's an open source thing, is it?
I'm not sure, but we're having people bring out a amplifier that they'll send a signal through. Hopefully it'll do the voltage and amps we want to get that ozone smell out of it.
So what's the setup that they need to do? What's the circuit that Daniel explained? Can you remember?
So the signal goes around like this, and at the ends it's open.
Even if that's
Okay.
Yeah.
people start the video, they'll see that and they'll be like, oh, these things are great.
It's really a fear. I haven't gained up the courage to figure out straight.
I just noticed this creates a positive that's not necessarily true. It might be that it's just isolated from ground, so that you can. I actually run OS X, but right now I'm running Ubuntu because the other day I was doing something that you can't do in OS X. And Ubuntu is a version of Linux that's really easy to install. Although actually now Ubuntu has gone, I don't know, they went crazy and it's terrible now. So now I actually run Linux Mint. But this is an old install, and it's hard to get 3 different operating systems to boot on the same Mac. So I'm not really going to change it until I have to. But yeah, I don't actually really run Ubuntu anymore. I run Linux Mint. But Linux is powerful because you can do anything you want without any arguing or fussing. And there's none of that stuff that Microsoft, Windows, or even Mac forces you to do just to make them happy. They're like, oh, you need to. I don't know. It's made by people with the same intentions, the same desires for a free world.
So open source, is there any open source framework of this electronics center? Is there a kind of ethos of open source? You guys
Here at Noisebridge? Well, yeah, I think that people here are much more into open source than into closed source. The idea is that humanity was founded based on mutual aid. That's like why we have communication. If people were just fighting with each other all the time, we wouldn't need words. And the thing that evolved us and separated us from the animals that are just fighting for something is that we can work together. And open source is the concept that if I come up with an idea of how something works, and I can explain it and publish that for anybody who wants to use that for anything, then hopefully they won't use it for war, but instead we'll use it for cooperation, and we'll make the world a better place for all of us, for everybody.
Very exciting.
I can't believe you have this running on a light.
Well, this fluorescent light doesn't create. Yeah. If it's out of the sun, it's pervious. So it straight into an outside that just had a DC power cord going.
Haha. What is it saying? It's saying linear methods. Never mind. Anyhow, we can't smell ozone. Our last test is to see if we can smell ozone. Daniel says, if you wind this up like a unification coil, then you can smell the ozone. Easy peasy, just turn it on. Get it into resonance at high voltage. Not that high compared to how much you need normally to get this, to get ozone, and you'll smell ozone. So that is an anomalous phenomena that we are trying to demonstrate. However, it's not set up to. It's not wrapped like a unification coil with extra windings and a Rodin spiral to concentrate the magnetic field. It's just wrapped like a single Abha. So where was that 1830 where we got that?
600, 700, 800
800 what?
volts.
No way.
Yeah.
So you're generating 800 volts now. How come it's so much more? Oh, you're just measuring it properly.
Well, I'm just measuring where it should be open. Remember, he said.
Yeah. Okay.
I hear a slight tone,
I see.
but it's bouncing back and forth. It drops and increases, drops, increases.
Okay, so unfortunately for us linear thinkers, the best demo that we're going to be able to get is perhaps when I get back to New York and Daniel wraps it up for me as a Utron. It's another 500 buckaroons. But yeah, then it should pour off ozone. People go, that's strange, that shouldn't happen at these temperatures. I don't mind looking like a fool. I'm pretty sure I have to.
Okay, this thing keeps increasing the higher the frequency we give it.
Really?
I say we keep going.
Yeah. That sounded like going down. What are you at?
600.
600 volts. What's the current going through there? You don't have a measurement.
No, I'm not measuring current.
Okay, well what you got now?
It's bouncing up and down because it's modulating itself. I don't know why, but it's just modulating itself. It goes up and down to 8, 12, down to 6, 2. There's a sweet spot around. Let's see how far down.
I reckon 1830.
Yeah.
That's pretty stable. What's your volt levels? 500, 700, 6.5, that's down 8, 8, 7, 8, 6, 7,
It's about 19.44.
6, 7. What's 19.44? That's the signal.
Yeah, 19.6.
7, 5, 6. This one 8, 8, 7, 8, 8, 8. Yeah, that's good. 5, 7.
That's 500 volts per division. Oh, I guess it could go up to 2,000, 4,000 maybe.
Okay.
That's 100 times probe we're using. It's fixed. So
So,
that's what it
smelling
seems.
any ozone?
I'm not sure.
definitely has an effect.
I keep thinking there's a slight wind coming up.
I'm not smelling anything like that. We'll wait till we get to the upper part. I mean the unification. Waves, non-linear, and sinusoidal curvy waves, which you'd think are less linear. Why are they linear?
Well, you carry more frequencies with a square wave than with a sinusoidal. Like harmonics. We get higher voltage when we do square waves on the output, or the open windings for this. But you don't with a sinusoidal. I'm sorry. We're definitely introducing harmonics and this thing seems to respond with square wave better than without it, with sinusoidal. There's a sweet spot around 20 kilohertz. It starts raining again. I'm getting hot. No.
Can we put some Beethoven to it?
You could do anything you want.
This isn't a magnet, surely. It doesn't move at all. Okay, can we try some Beethoven?
Yeah.
Can't hear anything. Yes, I can. Okay. With Kirkwood, and what is your Japanese friend doing?
Kirkwood, we had a sinusoidal, and the frequency was different, I believe, but the fundamental that we're hitting could have been a subharmonic of the actual frequency. Anyways, we're pulsing it harder now with square waves, and it's introducing a lot of harmonics, and we find a sweet spot around 19 kilohertz, 19.1, 9.2, and it starts ringing again at that frequency. You could hear it, but the voltage also increases to 800 volt peak. That's just what I'm reading directly from from it.
Okay, and your friend in Japan, what does he say he's doing to get more volts out than his model predicts?
He takes inductors or a transformer and he pulls them hard so that he introduces second and third order effects in the magnetic field, and when it collapses and comes back into the system, he notices higher voltage than what the model says, and the only way he can account for that is the rate of change that he's driving these things. But he's also in his papers that I forwarded to you guys, he's varying the inductance to get it to work. I don't know how he's doing it now, but he's saying that he gets the second and third order effect